Welcome back everyone. In this lesson we are going to be creating our player game object. This is going to be basically the object or the collection of various different objects and children objects that is going to make up our player. Okay, and this is going to feature basically a root object for our player. As a child of that, we're going to have a 3D model and a camera. Okay, so we can look around. Now to start off with, I'm going to create a new empty game object here in the hierarchy, and I'm going to call this one player. Set the position to be 0, 0, 0, so it is nice and centered in our scene like so. And then what we're going to be doing is creating ourselves a little 3D model here. Now eventually we are going to be adding in a fully animated 3D night model here, but for now, let's just add in a basic capsule, okay? So I'm going to right click on player, go 3D object, and then capsule. This is going to create us a little 3D capsule right here. And what we need to do is actually change the size a bit. So first of all, I'm going to move it up so it is sitting on top of this grid plane here. So set that to a Y position of 1. And then what we're also going to be doing is reducing the width and the length of it a bit, just so it is a bit skinnier. So I'm going to set the scale here on the X to be 0.7 and 0.7 on the Z, just so we have a better idea of the dimensions of our player. Now, when it comes to our player as well, we're not going to be having the collider on our model, so we can go to our capsule here, right click on the capsule collider and go remove component. And instead, we're going to have a capsule component on our player. So I'll select our main player root object here, click add component and look for a capsule collider like so. Now, as you can see, the dimensions aren't really that good, so what I'm going to be doing is setting the center on the y-axis to be 1 and the height to be 2. We can also set the radius here to be 0.4, so it's a bit skinnier as well, and there we go. That is our capsule collider added to our main player object. And the reason why we're doing it this way is because with our model, you can see that the scale is a bit off. And if we do want to have our player object here have a 3D model that is a bit of on a bit of a different scale or a bit of a rotational offset, we can do that without having to modify or keep in mind the new forward direction or the new scale of our player. We can just have a set 111 scale on our main player and have the forward direction be the exact same. Okay, it just makes it a lot easier to work with if we have a consistent scale on our main player object. So you can see here we have the blue arrow pointing in the forward direction on our main player object. So that means our camera needs to be behind our player around here. And to do that, we can just select the main camera and drag that in as a child of the player. But this isn't going to work. We could have it like this, but when it comes to setting up the camera orbiting around the player, we need to set up a camera anchor, which is going to basically be the pivot point that we are going to be rotating around. We can do it without that by just feeding in a raw position just above the player's head, although that does require much more calculation. So having a camera anchor just on the player's head here and having the main camera as a child of that will make the process a lot easier. So I'm going to right click on player, go create empty, and I'm going to call this one our camera anchor. And I'm going to set this to a position of around, let's just say 1.9 or 1.8 on the Y here. So it is basically in the middle of the player's head right here. And then what we can do is drag in the main camera to the camera anchor, like so. Okay. Now with this main camera object, what we want to do then is change its position to be somewhere that is nice and close to the player and at a bit of an angle. So what I'm going to be doing is selecting the main camera. I'm going to go to our game view here and we're going to try and position it in an area that looks good. So first of all, X, we can keep that at 0. Y, I'm going to probably put this at around 0.5, so it is a bit higher than the camera anchor. The Z, we can bring that right back to around -3, and we might also want to rotate the camera down a bit, so I'm going to set the X rotation here to be 15, and we might want to increase the Y to 1. So you can see then we have a sort of above the shoulder view or above the head view of our player right now. But normally in action RPG games and third-person games, you have the camera at a bit of an offset from the player. You don't normally have the camera right behind the player's head. Instead, you'll probably have it a bit to the left or a bit to the right of the player. Well, in this case, we can just select our camera anchor right here, and move it along the x-axis. So we can maybe set the x to be 0.5, so we do have it at that bit of an offset, and this is going to be where the player's sword is. They're going to be holding a sword in their right hand, so we sort of have a straight on view of what they're going to be attacking, okay? And this part is entirely up to you if you want the camera to be closer, further away, at a bit more of an angle, or at a bit more of an offset horizontally. That is entirely up to you, okay? But this is what I'm going to have right here, and at this point we are pretty much done with our player object. We have all of the game objects set up. Now all we need to do is add the rest of the components. So first of all, back in our scene view, I'm going to select our main player object right here, and we are going to be adding in a rigid body. Now a rigid body, this is going to apply physics to our player, because with our player we want to be able to move around, jump, be affected by gravity, so this is why we need a rigid body. In terms of modifying these values, all we are going to be doing is opening up the constraints tab right here and enabling freeze rotation on the X, Y, and Z axes. This will basically make it so if we hit a tree or hit a bump, or if the enemy runs into us, we are not going to just fall over and land on our sides, because at that point we won't really be able to do anything. So we're making it so that the player's rotation is not going to be affected by physics, only its position, which is generally what you want in a game. You don't really have a third-person action game where the player can fall over sideways and not really do anything. So we'll freeze the rotation there, and apart from that, that's all we're going to be doing on our rigid body here. Everything else is built in and pretty much done how we'd like. Now, along with this, we are also going to be needing two scripts for our player. We're going to be needing a player script, which is going to control most of the player's actions, and then a camera orbit script, which is going to manage the orbiting of the camera. So I'm going to go to our scripts folder here, and I'm going to create these two scripts right now. So we have our player script, and we have another C# script called camera orbit. Okay. And I'm just going to then attach these to our player game object right here. So drag that in like so, and drag that in like so to the inspector. So now on our player, we have our transform component, our capsule collider, our rigid body, our player script, and our camera orbit script. And that is everything set up and ready to go. Finally, in this lesson, what we're going to be doing is just setting up a little bit of a platform underneath our player so they can walk around. So I'm just going to right click in the hierarchy, go 3D object plane, and I'm going to increase the scale, set the position to 0, 0, 0 first, and just set the scale to 2 by 2 by 2 by 2. So there we go. We have a slightly large platform here. If we look in the game view, there we go. So in the next lesson, we are going to be working on our camera orbit script, okay? We're going to get the camera orbiting set up and ready to go, and from there, we can then implement player movement, jumping, attacking, and so on. So, thank you for watching, and I'll see you all in the next lesson. Welcome back, everyone. In this lesson, we are going to be working on our camera orbit script. We're going to be setting it up so that we can rotate our camera around our player. So to do this, we are going to open up our camera orbit script, which we created in the previous lesson and attached to our main player object right here. So let's just double click on camera orbit to open it up inside of Visual Studio. Okay, here we are. First of all, what we're going to be doing is deleting the start and update functions right here. And inside of this class, what we're going to do, first of all, is create our variables. So first of all, we need a variable to keep track of the look sensitivity. Basically, how far is our camera going to rotate based on distance that our mouse moved. So we'll go public float look sensitivity right here. And then what we also need is two variables to keep track of our min and max X look. So how far down can we look and how far up can we look? Because without this, that means we can just rotate our camera 360 degrees up and around, which we don't want. We want a maximum height that we can look up to and a maximum distance that we can look down to. So we're going to create two variables, one called public float min X look, because X is going to be the up and down rotational axis. And then we need a public float for the max X look. Okay, so we've got those two variables there. Now we also need a variable to keep track of our camera anchor object, because this script is attached to our player, not the camera anchor. So we need this camera anchor referenced as a transform variable. So here we'll go public transform cam anchor, like so. Okay, so we've got that. And finally, one last variable. Actually, we'll have two more variables. We're going to have a public boolean, and this is going to be true or false for invert X rotation. So basically, some people, they prefer to have it so that when you pull the mouse down, the camera rotates downwards, and if you push the mouse up, the camera rotates upwards. Whereas some other people prefer it that if you pull the mouse down, the camera looks up. And this is entirely up to preference. Some people prefer normal camera rotation. Some people prefer inverted camera rotation. Okay, so we're going to have the option there available, so we can enable or disable that. And then we also need a private float variable to keep track of our current X rotation, okay? Because our X rotation, we'll be needing to store this and check it every single frame for when we rotate it up and down. We need to make sure that this does not go above the max X look or below the min X look, okay? So we've got those variables there. Now the function that we are going to be working in will be the late update function. Now I'm sure you've all heard of the update function, which gets called every single frame. The late update function is basically the exact same, but this gets called at the end of the frame. So once all the other update functions have been called, just before it goes to the next frame, late update gets called. And the reason why we're doing this in late update is because if we do have this in update, there's a chance that this function could be called before our player's movement functions get called. And the reason why that's a problem is because we don't want to be rotating our camera before our players move, because depending on a number of different factors, it can result in jittery camera rotations, okay? So we're going to be doing our camera calculations at the very end, so it will be smooth. So here we're going to go void late update. You can see it is a function that can be automatically created, and it should be highlighted in blue here to show that it is a mono behavior function. So inside of late update here, what we're going to be doing is, first of all, we need to get our X and our Y mouse inputs. We need to know how far our mouse has moved each frame. So here we'll go float X equals input dot get axis, and to get the mouse axis, this is going to be mouse X, okay? Mouse X being left and right. So if our mouse is not moving, this value will be 0. If our mouse is moving left, it will be -1. And if our mouse is moving right, that will be +1. And that number will be higher if we're moving our mouse faster to the right, or that number will be even lower if we are moving our mouse faster towards the left, okay? So it does take into consideration the speed of the mouse as well, not just the direction that it's moving. And along with this, we also need to get our vertical mouse movement. So we'll go float Y equals input.getAxis mouse Y, which is the exact same, but for moving it up and down. Okay, so we got those two variables now. What we can do is rotate the player along the vertical axis, because when it comes to rotating the camera, we are only going to be rotating the camera up and down. When moving our mouse left and right, we're not going to be rotating the camera anchor. Instead, we are going to be rotating the entire player, because in many third-person games, you have it so that if you're looking left and right, the player rotates along with that, okay? So the player is always looking in the horizontal axis that you are rotating the camera in. And that just makes it a lot easier to play with, so we're going to be doing the exact same here. So to do this, we are going to go transform to access the main player transform component, dot Euler angles, which is basically the rotation, as a vector 3. And we are going to add to this. We're going to add to our current rotation by going plus equals, and the axis that we want to rotate along is going to be the y-axis. If we are rotating along the y-axis, that is the vertical axis, that means we are going to be looking left and right. We're going to be pivoting from the left to the right horizontally. Okay, so we'll go vector 3 dot up. And then multiply this by the X input, so how fast is our mouse moving, and then multiply that by the look sensitivity. Okay, so that is going to rotate our camera left and right, or in reality, rotate our player left and right. And as a matter of fact, let's save this script and go have a look and see if it works. So I'm going to go back to Unity here. I'm going to select our player object. I'm going to go down to where we have our camera orbit script, and we're going to fill in these variables. So first of all, look sensitivity, I'm just going to put this at 1 for now. Our min X look is the lowest we can look, and I'm just going to put this at probably something like negative, let's just say negative 60, and positive 60 for the max. The camera anchor, I'm just going to drag in our camera anchor transform like here, and invert X rotation, we'll leave that disabled for now. So we can save that, press play, and we should be able to move our mouse left and right. And as you can see, when I move my mouse left, our player is rotating left, and when I move it right, our player is rotating right. So it looks like we have that horizontal mouse movement or camera rotation implemented right now. Now it does look like our player isn't actually rotating, but it actually is, because if we look in the inspector here, you can see the player's Y rotation is moving as we rotate the camera around, while the camera anchor's Y rotation stays the same. Now for vertical rotation, we're going to be rotating along the camera anchor's X rotation here, and you can see if I modify that right now, you can see this is what it is going to look like once we implement that. Okay, so I can unpress play here, and we can then return to our script where we are going to be implementing the vertical rotation. And this is a bit more complex compared to what we've done right here. Right now it's just one line of code, whereas with vertical rotation, we do have to keep in mind that we have the minimum X look and the maximum X look. So we have to take into consideration how far up and how far down we can look before affecting our camera's rotation. So we'll be continuing on with this script in the next lesson. So I'll see you all then. Welcome back everyone. In this lesson, we are going to be continuing on with our camera orbit script in rotating our camera left, right, and up and down. So in the previous lesson, we set up horizontal camera rotation. Here inside of the late update function, we are getting our mouse's X and Y inputs. So if we're moving it left and right or up and down, we're getting basically the value or the direction and speed at which we are doing that. And here we are applying that to our player's horizontal rotation so we can look left and right. Now what we need to do is have the ability to look up and down. And to do that, what we need to do first of all is instead of modifying our camera's rotation directly, we are going to modify this current X rotation variable, which we created. So here we are going to go cur X rot plus equals Y multiplied by look sensitivity. Okay, so we're adding basically however far we moved our mouse multiplied by the look sensitivity to this current X rotation value. And now what we need to do then is clamp this, and clamp basically means we have a value and we basically force it to be in between a minimum and a maximum value. The minimum being the min X look and the maximum being the max X look. Okay, so we are sort of restricted in how far up and how far down we can look. And to do that, we can go cur X rot equals mathf.clamp, and with this function, we give it 3 values. The value we want to clamp, the minimum, and the maximum. So the value is going to be the current X rot, the minimum is going to be the min X look, and the maximum is going to be max X look, okay? And there we go. We've clamped this value now, so it can't go above a certain value or below a certain value. Now what we need to do is apply this to our camera's rotation. So what we're going to do first of all is create a local variable which is going to store the current camera's rotation, so then we can apply this new value to it and then assign that back to the camera. Okay, so what I'm going to do here is go vector3 to create a new variable called clamped angle, and this is just going to be equal to our current camera anchor, cam anchor I mean, dot Euler angles. Okay, so we're getting the current camera's rotation and assigning that to this clamped angle variable here. Now what we're going to do is just go clamped angle, not camera anchor just yet, clamped angle dot X equals cur X rot like so. Okay, so we're assigning the X rotation, and then finally we can just go cam anchor dot Euler angles equals clamped angle like so. Okay, and that is how we do the up and down rotation. Okay, so quick overview. Here we are getting our inputs from our X and our Y on our mouse. Here we are rotating the player left and right. Here we are adding on our mouse's up and down value to our current X rotation variable. Here we are clamping that variable to make sure it is in between the minimum and maximum X rotation basically barriers. Here we are creating a temporary variable and assigning that to our camera's current rotation. We are then assigning the X rotation or the X axis to be our current X rot, and then here we are applying that new variable to our camera's rotation. Okay, so we can save that. We can then return to the Unity editor right here, and let's press play and see if it works. So we can move left and right like before, and now we can look up and down. If I drag the mouse down, the camera looks up, and if I drag the mouse up, the camera looks down. Okay, so right now it is actually in inverted camera angle right now. So what we should actually do then is implement the ability to enable or disable inverted camera. So back inside of our script right here, we have this Invert X Rotation variable. Now let's implement that. So here is where we're going to implement it, where we go current X rot plus equals y times look sensitivity. Okay, now we are going to instead put this on a new line here and put this inside of an if statement. So here we are going to go if invert X rotation, then this is what's going to happen. Otherwise we'll go else, and then that's going to be current X rot minus equals y multiplied by look sensitivity. Okay, so if we are inverting the X rotation, then we're going to be adding this. Otherwise, we're going to be subtracting this. Now, you might be used to if statements with the curly brackets, but in C#, it's a pretty cool thing. If we are only having one line inside of our if statement, we don't actually have to put any curly brackets. So it does save up some space in terms of lines of code with the curly brackets. But do keep in mind that this is only possible if you have only one line of code under your if statement here. Okay, so there we go. We can save that. We can return to the Unity editor now and test it out. So if I select the player, you'll see that Invert X Rotation is off. So we should be able to pull our mouse down to look down, pull it up to look up. Yet if I enable that, we can then pull our mouse down to look up and pull it up to look down. So there we go. We have Invert X Rotation enabled now. You can of course go through, modify the look sensitivity. We can maybe increase it to 1.5 if we wish. And something else that we might want to do that may be bothering you is disabling the mouse cursor, because right now we see our mouse cursor on screen, and eventually once we implement the ability to attack enemies by left clicking, we don't want to accidentally have our mouse over maybe on the X here and accidentally left click and close the program. We want to make it so our mouse is constrained to the game window here and invisible. And we can easily do that with one line of code inside of Unity. So let's open up our C# script here, and I'm going to go and create the start function. So right at the start of the game, this is what we are going to do. And inside of here, we are going to go cursor.lockState equals cursor lock mode dot, and you'll see there are a number of different things here. You have confined, which basically confines it to the game window. Locked, which basically locks it to the center of the game window and also makes it invisible. And none, which just makes it behave as it is normally, pretty much what we got right now. So I'm going to set this cursor to be a cursor lock mode of locked. Okay, we can save that, return to the Unity editor, and when we press play, you'll see that our mouse disappears. And we can look left and right as much as we want, so I can spin the camera continuously along the right hand side here, and the mouse is not moving off the screen or getting stuck, which is very nice. Okay, so we've got our camera look set up and ready to go. We can look up, we can look down, we can move our mouse left and right to rotate around. Now what we need to do is implement the ability for our player to move around and have the player move relative to where we are looking with our camera. So if we're looking over here, if we press W, we want to move in this direction. If we look over here and we press W, we want to move in this direction, okay? And all the other controls, so left, right, and backwards, should also be relative to the direction that we are looking at. Now, if you're on the screen, you may be wondering, okay, how do I get out of play mode? Because you can't click on any of the buttons here. Well, what you can do is click the escape key, and this will re-enable your mouse cursor, and if you click back on the game window, it will toggle it back like here. Another way to stop playing the game is by holding down Control and pressing the P key, or Command P if you're on a Mac, and this will basically toggle play mode. So, thank you for watching, and I'll see you all in the next lesson. Hey everyone, in this lesson we are going to be implementing player movement into our game. In the previous lesson we set up our camera orbit so we can now look around with our camera. So let's start implementing the ability to move in the direction relative to where we are facing. So I'm going to open up our player script, which we have created down here. And inside of our player script here, I'm going to start off by just deleting the start and update function since we don't need those just yet. And we will begin by creating some variables. So for movement, we need a few things. First of all, we need to have a public float variable for our move speed. So how many meters per second are we going to be moving at? And then we also need our rigid body component, which is going to be basically a variable that is going to reference our rigid body component, as the way we're going to be moving around is by setting our physics velocity. Okay, so here I'm going to go public rigid body, rigid body like so, and I'm just going to call this one ridge. Okay, so we've got our two variables there. Now what we're going to do is create a function called move. So we'll go void move like so. And this function is going to be called every frame. Now, in order to have this function actually be called, we need to call it inside of the update function, which gets called every frame. So up here, I'm going to create the update function. And inside of the update function, we are just going to call our move function every frame. Now, the reason why we aren't just having our move code inside of the update function, well, we could do that, but the reason why is because we're going to have a number of different systems as well, and this just makes it a lot easier to understand when looking at it for the first time. We can see, okay, we are calling move, and all of our move code is contained inside of one function. It just makes it easier once you have a bunch of other systems as well stacked on top of this, just in order to understand it, okay? Now, in order to move around, we need to get the input from the player's keyboard. So we need to be able to get the left and right axes and the up and down axis. Similar to how we done it with the mouse, where we were able to move our mouse left and right to get the X and up and down to get the Y. We can get our keyboard horizontal and vertical axis. The horizontal being the A and D keys, A being -1, D being +1, and nothing being 0. Alternatively, we could also use the arrow keys, so left and right arrow keys will move horizontally as well. And for vertical, this is the up and down arrow keys, or the W and S keys. So here we're going to create a float X called, or a float variable called X, and this is going to be equal to input.getAxis, and this is going to be the horizontal axis like so. It's going to be between -1 and 1. -1 for if we are pressing the left button, and +1 for if we are pressing the right button, and 0 if we are pressing nothing. Then we need the exact same this time for Z, which is going to be forwards and backwards, and this is going to be the input.getAxis vertical. Okay, we're getting the vertical axis here. And there we go. That's how we get our movement axes from our keyboard and storing them in as variables. Now what we need to do is assign this to our rigid body velocity. So we could just go, for example, vector3, create a new vector3 here called dir for direction. And this could then be equal to something such as new vector3. We give it the X, we set 0 for the Y, and Z for the Z here. Multiply that by our move speed, and there we go. Okay, and then finally we just need to go ridge.velocity equals dir. Okay, so we're setting our velocity to equal this new directional velocity here. Now this isn't what we are going to be doing in the final product, but I'll just show you that this is a rough example of how we can get something like this set up and moving. So we can save the script, return to Unity, we'll select our player and give ourselves a move speed of around, let's just say 3, drag in the rigid body component, and press play, okay? So we're here, you'll see if we move right, and then left, back and forwards, we're pretty much moving in the way that we should. We could probably even boost up our move speed to something such as 5 here. There we go, we can move left, we can move right, we can move backwards, and we can move forwards. But look what happens if I move to the left here, and then, or if I rotate the camera to the left and then start moving. You'll see that our controls are not relative to the direction we are looking at. If I press W to go forward, we're moving to the right. And that is the problem we have to fix right now. So I'll go Control P to unpress play. I'm going to set the move speed to 5 right here. Now back inside of the script, what we need to do is make it so that whenever we are moving forward not based on the world direction, but based on our local direction, based on the direction that our player is facing, okay? And in order to do that, we need to do this tiny little algorithm here, which is just going to get our transforms forward and right directions and multiply those by our inputs here, okay? So instead of direction equaling this here, we're going to delete that. Okay, so it's going to be vector3 equals transform.right, which is our right direction, multiplied by x, plus transform.forward multiplied by our z, which is our forward input, our W or S or up and down arrow key. And there we go. We are now getting a relative direction based on where our player is facing when we are pressing our inputs, which is great. Now finally, we just have to multiply direction by the move speed, so multiply that by move speed, and then we need to set the y direction to be whatever our current y velocity is, because if we were to fall off an edge, we don't just want to hover midair, we want to continue falling down based on gravity. So I'm just going to go dir.y equals ridge.velocity.y. And there we go. That's what we need to do in order to get this relative directional movement. So we can go back to the Unity here, save that, press play, and as again, you can see I can move forward, back, left, and right. But if I face the side here and do the same, I'm also moving forward, back, left, and right relative to wherever we are moving. You can see if I hold down W and rotate the camera around, we are now moving in a circle, which is great. This is exactly the sort of behavior that we want from our player here, our player movement. Okay, so we've got all this set up. Now, one more thing to finish this off is the lighting. As you can see here, although this is just a test environment where we are just testing out the base mechanics with no amazing graphics or anything, you'll see that the lighting is very harsh. Over here, it's not even that bright, yet in the shadows, it is pitch black. And the reason why is because currently, auto-generate lighting is off. In Unity, we are using real-time lighting, which basically means each frame it is calculating where the shadow should be and the luminosity of everything. And that's not really being done correctly, so we need to go down to the bottom right corner of the screen and select this auto-generate lighting off button. This is going to open up our lighting screen right here, or lighting window, and we just want to enable auto-generate right there. And then we can just close the window, and there you go. You can see that our scene is now correctly lit. It's got the nice shadows, no more harshness there, and the ground is white, which is the color that it should be. And to make our player contrast from the ground a bit more, because right now they do blend in a bit, I'm going to go ahead, go to the assets here, and create a new folder called materials. And we can, of course, delete this in the future once we actually get our proper environment. And inside of materials here, I'm going to create two materials, one for our player and a material for our ground. Okay, so these are both going to have different colors. So in our scene view, I can drag on the ground, drag the player onto our player, and then we can set them. So for the player, I'm going to give them a red color, and for the ground, I'm going to give that a green color, something like that. Okay, and there we go. We can press play and test this out in our game. And as you can see, we can of course move around, but now we need to jump. And we are going to be working on jumping around with our player in the next lesson. So I'll see you all then. Welcome back everyone. In this lesson, we are going to be implementing the ability for our player to jump. Because right now we can move around, we can look around, but we don't have jumping enabled. So let's go over to our player script right here. And inside of this script, we are going to go up to the update function where we are going to be detecting inputs from our keyboard to check to see if we are jumping. So under where we are calling the move function here, I'm going to go if input.get key down, which is true on the frame that the specified key has been pressed down, and this key is going to be keycode.space. Okay, so when we press down the space bar, what we are going to do is call the jump function. So I'm just going to go jump right here, And let's go ahead and create that jump function just under move here. So go void jump like so. Now, when it comes to jumping, we need to know if we are standing on the ground because we don't want to be able to jump if we are mid-air. So the way we're going to be doing this is with ground detection. And inside of Unity, normally the best method of ground detection is by using a raycast. And a raycast is pretty much a line that you give a position to and a direction, and it shoots off like a laser. And if it hits something, it will tell us what it hit, how far away it was, and all this other information. Well, pretty much what we want to do is shoot a laser from the bottom of the player's feet downwards around 10 centimeters, okay? And if it is hitting something, then that must mean it is hitting a solid surface, meaning that the player is standing on the ground. Now, if that raycast is not hitting anything, then that must mean the player is mid-air, meaning we cannot jump. So I'm going to create another function underneath jump here, which is going to return a Boolean variable, and this is going to be can jump. Okay, and inside can jump here, what we're going to be doing is first of all creating a array called ray, and this is going to be equal to new ray. And with ray here, we need to give it two values. We need to give it an origin and a direction. The origin is going to be basically where the player's feet is, and the way we've set up our player is that the pivot point or the origin for our player is pretty much on their feet, okay, in the center of their feet. So we can just give ourselves the transform.position for the origin, and direction is going to be vector3.down, okay? So we are shooting a laser from our feet down towards the ground. Then we also need to create something known as a raycast hit, and a raycast hit is an object that contains the information about what it has hit, about what this ray has hit into along its journey. So here we'll go raycast hit, and we'll call this one hit. And this doesn't have to equal anything right now. In fact, we can then just go if physics.raycast, and this is how we can actually emit this raycast. We need to give it the ray, and then we can go out hit to basically output the hit information to this variable. And then we can give it a distance to travel at. Now, we only want it to travel a short distance, so we can just go 0.1f for around 10 centimeters. And there we go. We have cast a raycast. And then inside of this if statement, we want to see if this has hit anything. If this has hit something, then we are going to return true. Otherwise, we are going to return false. So in here, we're just going to go return hit.collider for the collider object that we hit doesn't equal null. So pretty much hit collider doesn't equal null is going to give us a true or false. This is a condition we are checking to see if what we have hit does exist. So does the object we hit exist? If it does exist, it's going to be true, and if it doesn't, it's going to be false. So can jump is going to return true for if we can jump, and false for if we cannot. Now you'll see there is a red squiggly line, and that is because if this if statement doesn't run, it's not returning anything. So under here, we can just go return false, okay? But most of the time, this is not going to be called. So now what we can do is over inside of our jump function, we can check to see if we can jump. So we can go if can jump. So we can call the if can jump function right there. Then what we are going to do is add force upwards to our player. And the way we can do that is through our rigid body. And as a matter of fact, let's go up to the top now and create another variable which is going to store our jump force. So we can go public float jump force. And this is going to be the force applied upwards to our player when they are jumping. So if the player can jump, if they're standing on the ground, what we want to do is just go ridge.add force. So basically add force can push an object in a certain direction. The direction and force we want to apply is going to be vector3.up. So we want to move upwards. And then we want to multiply that by the jump force. So we have this varying jump force being applied to the up direction. And then we want to go comma and then force mode dot. And you'll see there are 4 different force modes. Now in Unity, by default, it is acceleration, which basically means that you could think of acceleration as pushing a car or accelerating in a car. Once this car starts basically moving, it gradually increases momentum over time. Whereas if you were hitting a golf club with a golf ball, that golf ball is going to instantaneously move at its max speed, okay? So you can think of force mode in 2 different ways pretty much. you have gradual speed increase and instantaneous velocity. Now for us, we want to jump, so we want to be snappy. We want the player to instantly start moving upwards. And to do that, we're going to go force mode dot impulse, which basically means instantaneous movement. Add a semicolon at the end of that to finish off the statement, save it, and then we can return to the Unity editor. Now we can select our player and we are just going to give them a jump force. I reckon we could give them a jump force of around 5. That might be alright. We can of course change this later on. Press play and let's test it out. So we can move around, we can look around. Let's press space and there we go. We are jumping in the air. You can see our shadow there as we jump, and if I try and spam the spacebar, you can see I'm not jumping. I'm only jumping if we are standing on the ground and not mid-air, which is exactly how we want it. Okay, so that is our jumping mechanic set up and ready to go. Okay, so in the next lesson, what we're going to be doing is setting up our enemy, and the enemy is going to be an object which can chase after the player, and when it gets to a certain distance away from us, they will begin to attack us. And later on, we'll also then implement the ability for us to attack the enemy back. Okay, so thank you for watching, and I'll see you all in the next lesson.